In the realm of software development, clean code stands as a cornerstone of quality and efficiency. Clean code is not merely a matter of aesthetics, but a crucial factor that profoundly impacts the success and longevity of software projects. When code is clean, it becomes easier to read, understand, and modify, leading to improved maintainability, reduced bug density, and enhanced collaboration among developers. Conversely, poorly written, convoluted code, often referred to as spaghetti code, can quickly devolve into a nightmare to maintain, hampering development progress and increasing the likelihood of errors. One of the primary reasons why clean code is paramount is its impact on maintainability. Software systems are rarely static entities. They constantly evolve to accommodate new features, address bugs, and adapt to changing requirements. When code is clean and well organized, developers can easily comprehend its structure and logic, enabling them to make modifications swiftly and confidently. On the other hand, navigating through a labyrinth of tangled and poorly documented code can be an arduous and error-prone task, leading to delays, frustrations, and potentially introducing new defects. Moreover, clean code promotes collaboration among development teams. In today's collaborative software development environments, it is common for multiple developers to work on the same code base concurrently. When code is clear, concise, and adheres to established coding conventions, it becomes easier for developers to understand each other's work, share code modules, and integrate their contributions seamlessly. This enhanced collaboration fosters a more efficient and productive development process, ultimately leading to faster delivery times and higher quality software. In conclusion, clean code is not a luxury, but a necessity in software development. It is an investment that pays dividends throughout the software development lifecycle, from initial development to maintenance and future enhancements. By embracing clean coding practices, developers can create software that is not only functional, but also maintainable, robust, and scalable, ensuring its longevity and value over time. Writing clean code is a craft that requires attention to detail and adherence to best practices. By adopting a few key principles, developers can significantly enhance the clarity, readability, and maintainability of their code. One fundamental aspect of clean code is the use of descriptive and meaningful names for variables, functions, classes, and other code elements. Choosing names that clearly convey the purpose and functionality of these elements greatly improves code readability. For instance, instead of using a generic variable name like X to store a customer's name, a more descriptive name like customer name makes the code self-documenting and easier to understand. Similarly, function names should accurately reflect the actions they perform, making it intuitive for others and your future self to grasp their purpose at a glance. Effective use of comments is another essential element of clean code. While clean code should strive to be self-explanatory, there are instances where comments are necessary to provide additional context or explain complex logic. Comments should be concise, focused, and avoid simply restating what the code already explicitly states. Instead, they should offer insights into the rationale behind design decisions, potential pitfalls to avoid, or any assumptions made during implementation. Furthermore, breaking down code into smaller, well-defined functions is a cornerstone of clean coding. Functions should ideally adhere to the single responsibility principle, meaning they should have one specific task or responsibility. This not only improves code organization, but also enhances reusability and testability. Smaller functions are easier to reason about, debug, and test in isolation, leading to more robust and maintainable code. The dry, don't repeat yourself principle is another crucial tenet of clean coding, advocating for the elimination of code duplication. Repeating the same code snippets throughout a code base introduces redundancy, making the code base harder to maintain and increasing the likelihood of inconsistencies. By abstracting common code into reusable functions, classes, or modules, developers can reduce redundancy, promote consistency, and make the code base more manageable over time. In the realm of software development, the significance of well-organized and meticulously documented code cannot be overstated. While clean and efficient code forms the foundation of a maintainable code base, proper organization and comprehensive documentation serve as the pillars that uphold its long-term integrity. A well-structured code base, akin to a well-organized library, allows developers to navigate its contents effortlessly, locate specific components swiftly, and comprehend the relationships between different modules with ease. One of the primary advantages of a well-organized code base lies in its ability to facilitate seamless collaboration among development teams. When code is logically structured into directories, packages, or modules, each dedicated to a specific aspect of the application, it becomes remarkably simpler for developers to work on different parts of the code base concurrently without inadvertently introducing conflicts or dependencies that could disrupt the work of others. This modular approach not only enhances parallelism in development, but also promotes code reusability, as well-defined modules can be easily shared and integrated into other projects or parts of the application. Comprehensive documentation, on the other hand, serves as a living guide to the code base, providing invaluable insights into its architecture, functionality, and design decisions. Documentation should not be an afterthought, but rather an integral part of the development process. Inline comments, while valuable for explaining specific code segments, should be complemented with more comprehensive documentation that provides a high-level overview of the system, explains the purpose and functionality of different modules, and documents the APIs and interfaces that govern interactions between different components. Moreover, clear and concise documentation proves to be an invaluable asset during the onboarding of new developers. When new team members join a project, well-structured code and comprehensive documentation can significantly reduce their ramp-up time, allowing them to become productive contributors more rapidly. Instead of spending countless hours deciphering cryptic code or searching for information scattered across different parts of the code base, new developers can rely on the documentation as a roadmap to navigate the code base, understand its intricacies, and quickly come up to speed with the project's conventions and best practices. Section 4. Ensuring code quality unit testing and debugging. In the pursuit of delivering high-quality software, ensuring the correctness and reliability of code is of paramount importance. Unit testing and debugging emerge as indispensable practices in the software development lifecycle, enabling developers to identify and rectify errors early on, thus preventing them from propagating into later stages of development where they become exponentially more costly and challenging to resolve. Unit testing, as the name suggests, involves testing individual units or components of code in isolation to verify that they function as intended. At its core, unit testing revolves around the concept of isolating the smallest testable parts of an application, typically individual functions or methods, and subjecting them to a series of tests that cover a range of inputs, including both valid and invalid data, edge cases, and boundary conditions. By systematically testing these units in a controlled environment, developers can gain a high level of confidence in the correctness of their code and ensure that each unit behaves as expected in isolation. Debugging, on the other hand, comes into play when tests fail or unexpected behavior is observed during development or runtime. Debugging is the art of identifying, analyzing, and resolving defects or errors in the code. It often involves the use of specialized tools and techniques to track the flow of execution, inspect the values of variables at different points in the code, and pinpoint the root cause of the issue. Effective debugging skills are essential for developers to quickly identify and rectify errors, minimizing downtime and ensuring that the software behaves as intended. Modern software development environments offer a plethora of tools and frameworks to aid in both unit testing and debugging. Unit testing frameworks such as Junit for Java and PyTest for Python provide developers with a structured way to write and execute unit tests, automate the testing process, and generate comprehensive reports on code coverage and test results. These frameworks often integrate seamlessly with popular integrated development environments, further streamlining the testing workflow. Section 5. Version control, a safety net and collaboration tool. In the dynamic world of software development, where code bases constantly evolve and multiple developers often collaborate on shared projects, version control systems have emerged as indispensable tools that provide a safety net for code integrity, facilitate seamless collaboration, and enable efficient tracking of changes. Version control systems, often abbreviated as VCS, are software tools that allow developers to track changes to their code base over time. providing a comprehensive history of modifications, additions, and deletions. One of the primary benefits of using a version control system is the ability to revert to previous versions of the code base. This feature proves invaluable when developers need to undo erroneous changes, experiment with new features without affecting the main code base, or simply examine how the code has evolved over time. By providing a safety net to experiment without the fear of losing valuable work, version control systems encourage developers to explore new ideas and refactor code with greater confidence. Moreover, version control systems greatly facilitate collaboration among developers working on the same project. They allow multiple developers to work on different parts of the code base simultaneously, and then merge their changes seamlessly, minimizing the risk of conflicts and ensuring that everyone is working on the most up-to-date version of the code. Through features like branching and merging, developers can create independent branches of the code base to work on specific features or bug fixes without interfering with the main development line. Among the various version control systems available, Git has gained widespread adoption and become the de facto standard in the software development industry. Git is a distributed version control system, meaning that every developer working on a project has a complete copy of the repository, including its entire history, on their local machine. This distributed nature offers several advantages, including enhanced speed and efficiency, as most operations are performed locally, and improved resilience, as the repository is not reliant on a single central server. Section 6. Cultivating the art of clean coding. Mastering the art of clean coding is not a destination, but an ongoing journey of continuous learning, practice, and refinement. It requires a shift in mindset from merely writing code that works to crafting code that is elegant, maintainable, and a joy to work with. Like any craft, it takes time, effort, and dedication to hone the skills necessary to consistently produce clean code. One of the most effective ways to improve your clean coding skills is to make it a habit to review your own code critically. After writing a piece of code, take the time to read through it carefully, putting yourself in the shoes of someone else who might have to understand and maintain your code. Ask yourself questions like, is this code easy to understand? Are the variable and function names descriptive and meaningful? Is the code well organized and easy to follow? Are there any redundant or unnecessary parts? By regularly reviewing and refactoring your own code, you can identify areas for improvement and develop a keener eye for code quality. In addition to self-review, seeking feedback from peers through code reviews is an invaluable practice for improving your coding skills. Code reviews provide an opportunity for developers to share their knowledge, learn from each other, and catch potential errors or areas for improvement that might have been missed during individual development. When conducting code reviews, focus on providing constructive criticism that is specific, actionable, and aimed at improving the overall quality of the code. Furthermore, actively seeking out resources and engaging with the broader software development community can greatly enhance your understanding of clean coding principles. There is a wealth of information available online and in print, including books, articles, blog posts, and online forums that delve into the principles and best practices of clean coding. Participating in online communities, attending conferences, and engaging in discussions with fellow developers can provide valuable insights, expose you to different perspectives, and keep you abreast of the latest trends and best practices in the ever-evolving world of software development.